In C, there's something called malloc, which is used to dynamically allocate memory to pointers. Let's write out an integer pointer. So let's do int pointer ptr dynamic memory allocation. To do this, you write pointer is equal to malloc. And because we have an integer pointer, we're going to want to give this a size of an integer. So we can do size of int. And we want to typecast this to an integer pointer. Now, what you can do is you can write star ptr, and you can assign a value to the pointer at the dynamic memory reallocated. Now we can do printf value at ptr, %d, ptr, and this will display the value of our pointer. So let's do Control F5. Value ptr is 20. But when we dynamically allocate memory, we also need to free up that memory later in the program. C does not have automatic garbage handling, so if you have a bunch of dynamically allocated pointers, you'll have a lot of memory leaks, which is bad for the system. To free up allocated memory, you can use the keyword free and pass in your pointer. Now what this does is it will delete the dynamically allocated memory that we created on this line. So once your program is finished running, there's no more memory left in your system. One key thing to note is that you only need to use the keyword free if you use the malloc function to allocate dynamic memory. In the previous example, where you made the pointer reference an integer, you don't need free because you didn't dynamically allocate that memory like how you did with malloc. This creates memory out of thin air. So if we run it again, nothing happens, but now you'll know that we actually free up the memory once we hit this line here. If we go into the debugger and we press F5, you'll see that at the value here, we have a memory address and we have our value 20. Make it a little bit bigger. If I press step over, you'll see that it'll turn into a null value, which is a negative value, which means null. It deleted that memory there, and now it's freed up in our program.